Today we're going to talk about a strategy for microservices. My name is Stuart Williams, and I work for Magenic. What are microservices? Fundamentally, microservices are an architectural pattern. And the goal of the pattern is to avoid monolithic deployable units by breaking up services into smaller pieces. And you can take that all the way to the point at which you're deploying individual functions. Microservices happen either as part of an initial design or from a realization that a collection of existing services need refactoring. The goal is to have service units that version scale independently, that are simple to configure and deploy, and if they do have dependencies or connections to each other, that they do so via well-defined and simple interfaces. And like all architectural patterns, microservices have their pros and cons, use cases and anti-use cases. There's a lot of talk about microservices, but very little guidance on actual strategy, which is what we're going to try to do in today's brief video. So some definitions, and I'm going to focus on examples that come from the web API world, but microservices can be built with any number of technologies. They need not be web-based, although that's one of the most common methodologies. So we need to start with some definitions. An endpoint is the base address of a collection of services, and a service represents a collection of one or more functions. So we typically think of services as being the deployable unit, so that if we have in our technology stack a collection of functions that we want to deploy and version together, those are typically packaged and deployed as a service at a particular endpoint. And endpoints can usually host any number of services. Here's some example from the restive universe of different kinds of service URLs and sort of the very, very subtle disambiguations between endpoint services and functions. And typically speaking, addressing the base endpoint generally yields nothing or a generic sort of screen. In many cases, though, addressing the service endpoint specifically, whether it's in either subdirectory type folder structure or it's aliased to a DNS address underneath some domain, typically these yield some sort of document. If they are SOAP services, sometimes these addresses will redirect to the WSDL, or there'll be a covering document. If they're REST services, it's not unusual to see a redirection to the Swagger output or Swagger documentation pages, and other kinds of services have similar mechanisms. Typically, the point at which things get done in our definition is at the function level. Endpoint services and functions differ from each other. The answer, of course, is organization and intention. So organization is about how functions are lumped and split under services and endpoint collections, and intention is how the functions that are in that collection are going to be used. And these are incredibly subjective distinctions. Different authors or different architects will have different definitions of these. So with the stipulation that there are other services besides web services, and there are other service mechanisms for web services other than REST, we're going to use REST for our example throughout most of the presentation. So in REST services, we have made a convention that corresponds to the classic create, read, update, and delete mechanism against entities, with the corresponding verbs in HTTP and, for comparison, for SQL. So like many things in computer science, it devolves down to a lumping and splitting problem. We have a collection of functionality, and we're trying to decide how to break it up into reasonable units that go together. So if we're doing class design, we might consider domain-driven design or object-oriented analysis to help us make the lumping and splitting choices about which pieces of functionality go into what classes. Likewise, when we're considering services that are composed of functions that exist at an endpoint, we want to use a set of criteria that help us do the analysis of the lumping and splitting problem. So here are some common criteria. This is by no means an exclusive list, but it is a list of the ones that are commonly considered. So common entities are operations, a likely need to scale together, a shared security mechanism, the same backend data, the same availability, a common technology base, logical separation, coupling of service contracts or versions, need for facades or coordination between service endpoints. These are all a subset of all the different criteria that you could consider when thinking about the lumping and splitting problem. Bottom line, though, is we want to balance the number of deployable units with a need to treat one group of functions from another. Let's take a really simple example of a blog. So a blog is made by a person who creates posts. Posts have one or more associated tags. Posts can have one or more associated comments, and those comments are related to a person as well. This is a super simple example, but it makes it easy to diagram and understand as we go through our analysis. Here's a list, a partial list of the functions that we want to expose on top of the entities. And so we've made a chart, a little grid, and down the left we have numbered our functions that we know we have identified. We've nominated the associated entities. We've taken note of their security model. We've taken note of their likely scale units. And here, I'm just using high, medium, and low. In the real world, you'd probably try to make groups based on number of hits per second or hits per hour or per day or something. And then lastly, they're implemented on top of 3 different platforms. We've called them A, B, and C for simplicity. Again, if you do this exercise, you'll have enormously more function endpoints probably, and you'll have more in columns with different encoding. But again, for the purposes of this example, this is how we're going to lay it out. We're going to lay out 11 functions and a minimum number of entities and a fairly simple topology. So the technique that I like and I've seen used successfully on projects is that of making Venn diagrams. So this is a sample Venn diagram that tries to show the relationship between entities, scale units, platforms, and security models. And the F numbers correspond to the functions that we enumerated in the page before. And there are lots of different ways to do this, and it's an extremely powerful mechanism for trying to decide what can go together or be separate. And it's generally a good idea to make these diagrams starting with different starting points. Typically, I like to start with the columns that demonstrate the least variability. So in this case, the security column has the least variability, and then the platform column, and then the entity and scale unit columns, and so on. And of course, our functions are the things we're trying to allocate into different pools of functionality. Here was my final whack at it. There are many intermediate ones, but this is what I settled on. So from the most distinctive to the least distinctive, we have services that are anonymous, and we have services that leverage OAuth. Now, again, depending on your platform, you could probably combine functions that require the 2 different kinds of security into the same service. But here, happily, because I made the example work out that way, the anonymous things are all on a different platform than the mainline functionality. So we have Platform A, which provides a login, which is accessed anonymously, and what comes out is an OAuth token. And Platform C, which powers up our RSS feed for our blog, and doubtless has things to help it scale and cache the results and so on. If we look at the more complicated thing to the right, you can see things get much more interesting. So on the left, we end up with 2 fairly obvious service collections based on the fact that our take is that Platform A and Platform C and Platform B won't live nicely together. But on the right-hand side, you can see that we have some common groups of entities, and within those, what differentiates them is their desirable scale unit. And so if we were to count up only the groups of innermost services, you can see we have 1 here, 2, 3, 4, 5, 6, 7 groups that all have shared characteristics. So you could, if you wanted to, you decide that that is the allocation of your microservices. You're going to make a service, and the services will contain the endpoints that are inside the bubbles. But that's not all you could do. You could decide to go full microservice and make 11 different services. They could even have 11 different endpoints if you wanted to. But that means a lot of deployable units, and that might not be practical. Or you can have, if 7 deployable units is too many, you could combine the low and medium scale functions together on the grounds that the functions with low scalability requirements will benefit from running in a medium scalability environment, and it's unlikely to affect the medium scale collection of functions. Or you could combine all the related entities of the same scale unit. So you could say everything about customer and everything about posts and comments would sort of go together. Or you could use some other approach, depending on how you apportion function endpoints into different overlapping circles in your Venn diagram. The key takeaway to successful implementation of microservices from the design point of view is to do this analysis and to make a chart of the functions as you've seen before, to use Venn diagrams or some other analysis mechanism to decide what logically can go together and what cannot, and then use that to decide on how many deployable units you want to end up making, and then you can then fit that into whatever your technology delivery is, whether it's hosting on an Azure application platform, or different endpoints in Node.js, or different projects that you'll implement in Pivotal, or whatever. Once you have made the logical high-level analysis, the technology implementation should be fairly straightforward from a design point of view. The tricky part, of course, is the implementation can have nuances that aren't captured as part of this analysis. So there's my personal take on analyzing collections of functions to break them down into services and allocate them to endpoints using a strategy of a matrix and a Venn diagram. And I hope that was helpful. My name's Stuart Williams, and I work at Magenic.